Okay. A sound wave in a certain fluid medium is reflected at an obstacle to form a stationary wave. That means a sound wave solution, a sound wave is propagating through a medium. Medium is fluid, liquid. That means it is a denser medium. It is a denser medium. And reflected at an obstacle to form a stationary wave. And it reflects from a solid medium, say. And because of that, what happens? Stationary waves are set up in the medium. Stationary waves are set up in the medium. Okay. The distance between two successive nodes. What he has given? Distance between distance between two successive node equal to how much he has given? 3.75 centimeter. 5 centimeter. Distance between two successive nodes is given 3.5 centimeter, 75 centimeter. If the velocity of sound V is equal to, in that fluid is 1500 meter per second. 1500 meter per second. Find the frequency of wave. You have to determine the frequency of wave. So, what is the given data? Once again I repeat. A sound wave in a certain fluid, it is flowing through a liquid and reflects from a solid medium. Due to reflection, stationary waves are formed. And he states that the distance between two successive nodes, say this is antinode, point is antinode, node point and node point. Distance between two successive nodes is 3.75 centimeter. And the velocity of wave which is flowing through the fluid is 1500 meter per second. You have to determine n frequency. So we know that only one formula. We know V is equal to n lambda. That means from this formula we are able to determine frequency. But for that we need lambda. He has not given the lambda, but he has given the distance between two successive nodes. But that is also in centimeter. Velocity is given in meter. So it is in CGS unit and it is in SI unit. You have to convert it into what? In SI unit. 3.75 into 10 to the power minus 2 meter. 3.75 to 10 to the power minus 2 meter. So we don't know lambda, but we have studied that in the characteristics of stationary wave, we have studied that the distance between two successive nodes is lambda by 2. Distance between two successive nodes is lambda by 2, or which is equal to 3.75 into 10 to the power minus 2 meter, or lambda is equal to 2 into 3.75 into 10 to the power minus 2 meter. So we have determined lambda, we can determine n. Now V is equal to n lambda, or n is equal to V upon lambda. or n is equal to V. V is given 1500 divided by 2 into 3.75 10 to the power minus 2, or n is equal to 1500 divided by multiply by 2, we will get 057.5 into 10 to the power plus 2, or divided by 7.5, or 1500 divided by 750 into 10 to the power 2. If you remove a point and calculate it, we will get frequency is equal to how much? 2. The result is 20 into 10 to the power 6 hertz. Okay. Or we can write n is equal to 20 megahertz. How it is? Point कट केला 2 शून्य दिला 2 and 3 टाकले 3 sorry 10 to the power 3 kilohertz. Let us solve second problem. Next problem. Two sound waves travel at a speed of 330 meters. We have two sound waves. So first sound wave, second sound wave. Both are moving with the velocity of v is equal to 330 meter per second. If the frequencies are identical, the frequencies of both the waves are same, n is equal to, if the frequencies are identical, n is equal to 540 hertz. Medium is same, velocity is same, frequencies are same. What will be the phase difference between the two waves at a point 3.5 meter, and that means one wave covers a distance of 3.5 meter. Another wave covers a distance of 3 meter. Say, what will be the phase difference between these two from the origin? Let's say at the distance x1 is equal to, the phase is 3.5 meter, phase is phi 1. Phi 1 we don't know. And at a distance x2 is equal to 3 meter, the phase is phi 2. Phase is phi 2. What he has asked to determine? What will be the phase difference between the two waves at a point 3.5 meter from one source and 3.5 meter from other if the sources are in phase? What would be the phase difference? Phi 2 minus phi 1. Initially both the waves are in phase. They are starting at the same point, they are in phases, they are not in out of phase. So they cover different distance and different interval of time. Therefore, there will be phase difference between two waves. What he has given? Velocity he has given, frequency he has given. So for the first we have distance covered from the origin x1, 3.5 meter. You have to determine phi1. For second we have distance covered is 3 meter. The phase is say phi2. You have to determine phi2 minus phi1. Phi2 minus phi1. So, as in the earlier case, you are determining the phase, or you will write here. As you know that phi is equal to, in terms of x and lambda, 2 pi x upon lambda. Or phi1 is equal to x1 upon lambda. But phi1 is equal to 2 pi. x1 we don't know, x we know, lambda we don't know. But v is equal to n lambda. V is equal to n lambda, or lambda is equal to v upon n. V upon n. Or phi1 is equal to 2 pi into x1 divided by v into n. V into n. Or 2 into pi, x1 is 3.5. N frequency is 540 and V is 330. Or which is equal to 3.5 into 2 is 7 pi. 7 pi into 540 divided by 330. Okay. Let us calculate the phase in terms of pi only. In terms of pi. Or which is equal to pi into 7 540 divided by 330. Let us check once again the value. 2 pi is 2 pi x1 upon lambda. 2 pi x1, v is equal to n lambda, lambda is equal to v upon n. V, n goes in numerator. 2 pi x1 3.5, 540. Velocity is how much? 330. Frequency is 540. So this term, let us determine this term with the use of logarithm. So these two terms are in the numerator. So let them call as log of numerator. Log of 7. Log of 7. Log of 540. Log of 540. Log of 7, characteristics is 0. Characteristics is 0. In 70, in log 70, logarithm. 8451. 8451. And the characteristics is 1, 2, 3, 2.44 under 0, 7324. Add them. 5, 7, 7, 15, 3. So log of denominator, log of 330, 2.33 under 0, 33 under 0 is 5185. So log n minus log d, log of numerator minus minus log of denominator. What do we get? 3.5775 minus 2.5185. 0.9501 point. So let us determine the antilog of 1.0590. Zero five nine zero 1146 1146. So the phi 1 is equal to 11.46 pi. Here is we have determined, we have calculated this term in terms of, with the use of logarithm, we have got 11.46. Pi remains as it is, so pi 1 is equal to 11.46 pi radian. Similarly, let us determine pi 2. Pi 2 is equal to 2 pi x2 upon lambda, or similarly 2 into pi into multiplied by v is, here in this case we will get 2 pi, x is how much? 3 into 540 upon 330. Similarly we get pi multiplied by 6 into 540 divided by 330. So let us calculate phi 2. Let us calculate phi 2 with use of logarithm. There are 6 and 540 in the numerator term. So log of n, so log of 6 say, log of 6 is 0. Log of 60 is 7782. 7782. Log of 540, cat 6 is 2. Log of 540 is 2.7324. 7324. Add them. 6, 0, 10, 11, 1, 15, 5, 1, 3.5106. As usual, log of denominator 330, cat 6 is 2. Already you have determined how much it is, 2.518. So log of n minus log of d, that is log of numerator minus log of denominator. We get 3.5106, 2.5185. 1, 10 minus 8 is 2, 10 minus 1 is 9, 14 minus 5, 14 minus 5 is 9.0. Antilog of 0.9921, we get phi 2 is equal to 0.9921. 9819 or 9.819 pi. Therefore, we have to determine phi 2 minus phi 1. We have already determined phi 1, how much it is? 11.46. and phi 2 is 9.819. So phi 2 minus phi 1 will be phi 2 minus phi 1. How much it is? 11.46 pi minus 9.819 pi. Pi as it is, 0, 10 minus 1 is 1, 5 minus 1 is 4, 12 minus 14 minus 8 is 6, 10 minus is 1.6416 pi, 1.641 pi radian. So the phase difference is how much? 1 point, you have got 1.6416. Let us see what the answer he has given. Okay, 1.6416, right. Let us solve the third problem. Next problem. Two wires of same material. Two wires of same material means solution. Two wires of same material means their densities are same. Rho 1 is equal to rho 2. Or in other words, let us see what happens. The problem number is 14. Two wires of the same material and same cross section. Same cross section means A1 is equal to A2. Two wires of same material means densities are same. Same cross section means area A1 is equal to A2. Are stretched on a sonometer instrument. One wire is loaded with 1.5 kg. One wire is loaded with 1.5 kg. That means tension in the first wire is T1 is equal to 1.5 kg weight. 1.5 kg weight. A second wire is loaded with T2 is equal to 6 kg weight. 6 kg weight. It is known to determine in Newton. Okay. The vibrating length of first wire is, when first wire is subjected to the sonometer, the vibrating length between the two knife edges, that is L1. L1 is equal to 60 centimeter or 0.6 meter. And its fundamental frequency of vibration is same as that of second wire. That means when first wire is subjected to the sonometer and tension applied is how much? 1.5 kg weight T1. When second wire is subjected, tension applied is 6 kg weight. The vibrating length is L2. We don't know. In this case, important thing is the vibrating length of first wire is 60 centimeter and its fundamental frequency of vibration is same as that of second wire. That means both the wires are vibrating with the same frequencies. N1 is equal to N2. Both are vibrating with same fundamental frequency. What we have to determine? Calculate vibrating length of second wire. We have to determine vibrating length of second wire. L2. As he has already stated, both the wires are having both wires are same material, densities are same, cross section area is same. Tension applied to the first wire is T1 is equal to 1.5 kg weight. When the second wire is applied, tension is 6 kg weight. Vibrating length is L1 is equal to 60 cm. You have to determine L2. The important thing is both the frequencies are same. The vibration of first wire is same is equal to second wire. Now we know that fundamental frequency of vibrating of string is given by N is equal to 1 upon 2L under root T by M. Under root T by M. As cross section area is same, density is same, so N remains same, or we can write N1 is equal to 1 upon 2L1 under root tension is changing T1 divided by M, and N2 is equal to 1 upon 2 L2 under root T2 by M. You know that. He has given now N1 is equal to N2. Equating both the terms, we get 1 upon 2 L1 under root T2 by M. Sorry, T1 by M. 1 upon 2 L2 under root T2 by M. 2 get cancelled, M get cancels. We get under root T1 divided by L1 is equal to under root T2 divided by what? L2. Or L2 is equal to L1 under root L2 is equal to, you have to determine L2 is equal to L1 into under root T2 by T1, or L2 is equal to L1 means 0.6 T2 1.5. Six divided by 1.5. Or L2 is equal to 0.6 under root point get cancels, we get 60 divided by 15, 15 for the 60, 0.6 under root 4 or 0.6 into 2 or 1.2 meter. Okay. Same wire is given, tensions are different, lengths are different, frequencies are same, therefore we have equated the frequencies. When we get the frequency, we arrived under root T1 by L1 is equal to T2 by L2, or by substituting and calculating we get L2 is equal to 1.2 meter. Okay, next problem. Problem number 15. A pipe closed at one end. Solution. You have to remember pipe. Which type of pipe? Closed pipe. A pipe closed at one end can produce overtones at frequencies. Overtones of frequencies, say N1 is equal to 640 Hertz. He has given N2 is equal to 896 Hertz. And N3 is equal to 1152 Hertz. A pipe closed at one end. Which type of pipe? Pipe is closed at one end. Closed pipe produces overtones at a frequencies. Overtone, first overtone 640 Hz, second overtone 896 Hz, third overtone 1152 Hz. Calculate the fundamental frequency. We have to determine fundamental frequency N. Fundamental frequency equal to how much? So this problem is not based upon the formula, but it is based upon the concept. In physics, all the problems are not solved by formulas. Sometimes you have to use the concept. In this case, pipe is closed and we have proved that if N is fundamental frequency, first overtone is 3N, second overtone is 5N, third overtone is say 7N dash dash dash. In closed pipe, even harmonics are absent, only odd harmonics are present. Odd harmonics are present. That means they are multiple of N, or we can say if N is fundamental frequency, N1 is equal to 3N, which he has given 640 Hz, or N2 is equal to 5N, which is equal to what? 896 Hz, or N3 is equal to 7N, which is equal to 1152 Hz. So with the use of these frequencies, we can determine N2 minus N1 is equal to 5N minus 3N equal to, which is equal to 896 minus 640, 640, or 2N is equal to 6, 5, 256, or N is equal to 256 upon 2, or N is equal to 1.128 Hz. So we have determined fundamental frequency by using first and second harmonic, first and second overtone. We can also use first, second and third. We get the same result. You see, N3 minus N2 is equal to 7N minus 5N, which is equal to 1152 minus 896, or 2N is equal to 12 minus 6 is 6, 14 minus 9 is 5, 10 minus 8 is 2, 256, or N is equal to what? 128 Hz. So by using any of two successive two frequencies, we can determine fundamental frequency. 36 minutes. Okay, I think we have solved 5 formulas, 5 problems. Let us solve another one. Okay. A standing wave is produced. Problem number 16. Solution. Let us write data. A standing wave is produced in a tube open at both the end. That means pipe is open pipe. This you have to remember. The fundamental frequency of vibration is n equal to, as given, 300 hertz. What is the length of tube? You have to determine the length of tube. And here is also given speed of sound V is equal to 340 hertz. 340 hertz. In open pipe, in open pipe, stationary waves are formed. The frequency of vibration is n is equal to 300 hertz. The length of pipe with end correction is L is we do have to determine. Here your velocity V is equal to 340 hertz. We know that velocity of sound in an open pipe is given V is equal to 2NL, or L equal to V upon 2N. It is very simple problem. He has given V 340 divided by 2. N is 300. Fundamental N. N is equal to how much? V upon 2N, or 340 divided by 600. 0 goes. 34 divided by 60, or something is wrong. Okay, right. 6 5 are 30. 4 remains. Okay, 4 remains. 6 point 40 remains. 6 7 are 42. 6 5 are 30 again. 6 7 are 42. 6 are 36. Again 4 remains. 6 are 36. 6 are 36. Recurring deposit we get divided by 10. Or 0.5666 or 0.57 meter. 0.57 meter. So let us solve 17th problem. Find the fundamental first overtone and second overtone frequency of a pipe open at both the ends. Open at both the ends. Again the pipe is Again the pipe is open. We have to determine fundamental frequency. Find the fundamental. First order, say N1. Second order, N2. Frequency of pipe open at both the ends of length 25 centimeter. The vibrating length or resonating length or vibrating length of air column is 25 centimeter or 0.25 meter. Convert it into SI unit. If the speed of sound in air is V equal to 330 meter per second. Very simple problem. As we know, V is equal to 2NL. Or a fundamental frequency N is equal to V upon 2L. Velocity is 330. 2 into 0.25 or 330 divided by 0.5. Point get cancels, we get 0 or 3300 divided by 5. 6 5 are 30, 6 5 are 30, 0. So frequency N is equal to 630 Hertz. The fundamental frequency of vibration of open pipe of length 25 centimeter, velocity 130 is 660. Just now we have solved the frequency producing vibration of air column. If N is fundamental frequency, 2N is first order, what? First overtone, 3N is second overtone, what? 4N is third overtone, dash. We have to determine N1 and N2. Or N1 is equal to 2N or 2 into 660, that is 0 to 1320 Hertz. N2 is equal to 3N or 3 into 660, 0, 8, 1980 Hertz. So, by this way, 17th problem is also solved. 17th problem is also solved. Okay. We will stop here only because time is exceeded. 45 minutes has been over. Let us continue tomorrow.